Hello, welcome to Physics, a complete classroom series. Today's topic is behavior of conductors in electrostatic field. Net electric field inside of a conductor, that is net electric field intensity in the interior of a conductor is zero. When a conductor is placed in an electrostatic field, the charges, free electrons, drift toward the positive plate, leaving the positive core behind. At an equilibrium, the electric field due to the polarization becomes equal to the applied field. So the net electrostatic field inside the conductor is zero. Now let us understand this topic. It is one conductor. It is placed in a uniform electric field produced by a parallel plate capacitor. It is a positive plate, it is a negative plate. E naught vector, that is the external electric field, and it is now kept in this external electric field. Initially, the electric field also transmitted through this conductor, and the free electrons, they will be influenced under this electric field. Since these are free electrons, they start to move, and they are moving opposite to the direction of the electric field. That means they deposited here, and they leave the positive nucleus, and ultimately there will be a positive charge here, and there is a negative charge surface charge densities, and due to this positive and negative charge, one electric field, that is the EP, that is developed within this conductor, which opposes the E naught, and after some time at the equilibrium, the EP and E naught, these two will be same, and net electric field within the conductor will be zero. That means ultimately in static condition, there will be no electric field within the conductor, and it is always true. Now, point 2, behavior 2, electric field just outside the charged conductor is perpendicular to the surface of the conductor. Suppose the electric field is acting at an angle other than 90 degree. Then there will be a component E cos of theta acting along the tangent at that point to the surface, which will tend to accelerate the charge on the surface, leading to surface current. But there is no surface current in electrostatics. So theta 90 degree and cos of theta 90 degree, that means 0, cos of theta is 0. Let us suppose here. Now we can understand it. Suppose it is a charged one metallic object or conductors, and we assume that electric field is not perpendicular, that means normal to the surface. There is an angle theta with a tangent at that point. Therefore, there will be a component of E cos of theta along the surface, another component E sin theta, where it is a conductor, free electrons available everywhere, and there is a component of the E along the surface. Therefore, electrons will start to move along the surface, and we get a surface current, but we are considering electrostatic. That means when charged particles are at rest. Therefore, when charged particles are at rest, that means in electrostatics, electric field must be perpendicular, because E cos theta 0, that means cos of theta is 0, and it is possible when theta is 90 degree. Now next point number 3, behavior 3. The net charge in the interior of a conductor is 0. We are saying here conductor, these are not the insulators. The charge are temporarily separated. The total charge of the system is 0. Phi E, that is the closed surface integral of E dot ds is equal to Q divided by epsilon naught or epsilon. Since E 0 in the interior of the conductor, therefore Q is equal to 0. Now let us understand this topic. In electrostatics, within the conductor, there will be no charge at all. No charge at all. Let us suppose there will be some charge. Therefore, there will be electric field. And previously we know that there will be no electric field in electrostatics. until there will be equilibrium, and to take the equilibrium condition a fraction of second is required. After a fraction of second the E will be 0, and since there is no electric field, if you take any Gaussian surface within it, there will be no electric field, therefore there will be no charge. Here E is equal to 0, therefore Q is equal to 0. Now next 4 point. Charge always resides on the surface of a conductor. Always resides. Q equal to always 0 in electrostatics. And we are saying all these for the conductors only. Suppose a conductor is given some excess charge Q, construct a Gaussian surface just inside the conductor. Since E0 in the interior of the conductor, therefore Q inside the conductor equal to 0. That means since E0, if we take any Gaussian surface within this, since E0, therefore net charge will be 0. Therefore net charge. That means if you supply some amount of charge to the conductor, that charge will be certainly reside on the surface of the conductor. It may sometime fraction of second, but that charge always reside on the surface. There will be no charge inside the conductor in electrostatics condition. That means when there is no net flow of the charge at that time. Point number 5, electric potential is constant for the entire conductor. Then what will be the electric potential at each empty point? We know from the relation E is equal to minus dV dr. There is dV is equal to minus E dot dr. Here these are the vector quantities, E dot and dr. Since E is 0, therefore dV is the 0, and dV 0 means V not 0, V is the constant. And interestingly, electric field within the charged conductor will be 0, net charge will be 0, but potential that will be constant at each and every point. The potential at the surface inside any point on the conductor, that will be the constant, that will be the same. Now one related topics to this behavior of the conductor, that is the electrostatic shielding. What is electrostatic shielding? Electrostatic shielding, shield, that means it is protected from outer electric field, is defined as a phenomenon that is seen when a Faraday cage is used to block the effect of an electric field. The effects of external fields on the internal contents are blocked using the cage. Let us now explain. Electrostatic shielding applications. During the lightning of thunderstorm, it is advised to stay inside the car, not under trees or in the open ground, because the outer metallic body of the car act as an electromagnetic shield from the lightning. In coaxial cable, that you can observe in your TV cable line, coaxial cables, the central conductor is protected by electrostatic shielding by connecting the outer conductor to the ground. And let us understand these two topics, electrostatic shielding and their applications. So there are many applications. We are just saying about the Faraday cage. Now look at this figure diagram. It is one metal wall, that is metal box. Let us suppose any copper box, iron box, any one box, and that is known as any metal box or any cage type box made up of the metallic wire. It is known as the Faraday's cage. Faraday cage in the absence of an electric field. Now, when there is no electric field subjected to electric field, the charged particles are uniformly distributed over the whole wall of this Faraday cage. Let us suppose one electric field is introduced, external electric field. Electric field is just introduced, and due to the effect of the electric field, now free electrons start to move, and obviously free electrons move toward the opposite direction of the applied electric field, and they will start to move in these sides, and here the electric negative charges are accumulated, and obviously this side will be positive. And due to this, the electric field developed within the cage, that is opposite in direction, that is EP, and finally after a fraction of second, the electric field inside the cage or the box will be 0. Then that means there will be no electric field within the cage, since there is one electric field. applied to it, but there will be no electric field. Yes, that means any object kept inside the box, it will be free from the any external electric field applied to the box. And from this concept here, it is one figure diagram of the Faraday cage. It is one metallic cage, conductor cage, and there is a strong electric field outside of the cage, and the sparking is taken place. But inside that cage, that person is now safe because there is no effect inside the cage. There will be no electric field, and when no electric field, there will be no electric shock or electric current passes through our body. Now another advice, just you know, that is the when lightning taken place, it is advised to you, you should stay within the car, because car it is a metallic body and just behave like a Faraday cage. Even if a lightning and just on the lightning bolt on the car, the current that will passes through the tire to the ground. Since it is made up of metallic object, therefore there will be no electric field within the car and you remain safe. Now another behavior of the conductor when it is given some amount of electric charge. The surface charge distribution may be different at the different points. Even if surface charge density, that will be, that means surface charge density will be different at the different point. Even if on the same object here, on the same object, it is same metallic box, one side the surface charge is negatively charged, another surface charge density is the positive charge. That means surface charge, the value will be different, and the charge nature also may be different. Here it is negatively charged and positive charge, here surface charge density, negative charge density, and the negative charge density, these are also not equal at each and every point. Where it is a point is, that means radius of curvature at that point is less. At that point the density will be more. Here it is on figure diagram. Here the delta minimum, when the radius of curvature is the maximum, that means curvature is the minimum, and at that pointed edge the radius of curvature is very very small. Therefore the surface charge density sigma, that will have maximum value here. And on the basis of this concept, we construct a lightning conductor here. It is lightning conductor that is used to protect our tall structure like homes, tower, etc. From the lightning. That is one natural phenomena. uh, how it work, when any charged cloud that will be over any tall structure, any building, and due to the electrostatic induction, this lightning conductor will be charged, and the charge density will be maximum at the pointed edges. Therefore, where the charge density maximum, from that point, due to the high electric field, the charge start to emit from that, and there will be stream of ions, reduced charge on the clouds. And this is the induction due to the taken place, lightning rods, and in this way gradually the child cloud become neutral or toward the neutral. And if it is not ultimately possible to neutralize the cloud, then if lightning taken place, that lightning passes through this lightning conductor. But basic fact is the lightning conductor is act on this fact, that at the point edge the surface charge density will be maximum. Now it is the end of this video. For the next video, a link will be given this at the description box, and for this text you also get a link in the description box. And if you subscribe the channel, automatically you will be updated when any new video is uploaded. Now wait for the next video. Thank you.